So yesterday, or last lesson, we were talking about this idea of multiple dimensional arrays. A single dimensional array is just this one column here. A two-dimensional array is really an array of arrays. So inside of each array box is another array. That takes the form of a table. So inside the first box would be an array, index 0 through 3. Now you could make it index whatever you want. Inside the second box would be an array, again 0 through 3. However, you could make this one indexed differently. Maybe it's 0 through 10. Then this next one, maybe this one's 0 through 20. Maybe this last one is 0 through 3 again. But to be consistent, Java doesn't care, but to be consistent as a coder, whenever you're setting up a two-dimensional array or an array that is storing arrays, you want to make sure that every array in here is the same length. And once we start getting into the code for this, you'll see better why that's really important. To do a three-dimensional array, we would have our table, so to speak, but then in each cell of the table would be another array. So it's an array of arrays. And again, for consistency, you would make each array the same length. Java doesn't care if you do that or not. Java's fine with you make them all different lengths. Because as far as Java's concerned, it's just an object stored inside of an array that happens to be another array. It's like that movie Inception. The dream inside of a dream inside of a dream. Yeah. Don't worry. We're about to really get Inception. So the question then becomes, if you can represent each of these realistically, you could see a table, you can see a cube. How do you represent a four-dimensional array? Or a five-dimensional array? Or a 50-dimensional array? And what you have to do is you have to leave behind your typical construct for tables and move into a different type of design. And really see what's going on in memory inside of Java to figure out how this actually works. So, we go to a design that's more like this. So let's go through and explain this. Inside each array would be another array. So inside this array here, that's size 3, length 3, index 0, 1, 2, would be stored another array. But there's nothing that says you can't store arrays inside of each of those boxes. So what this ends up looking like is this. Hopefully I have a blank one. There we go. So we start with an array of length 3. Inside that array, I'm going to put another array of, let's say, length 2. So in terms of your perspective, we have a table that looks like that. 3 rows, 2 columns. But Java stores it like this. An array with 3 spaces, and inside each of those 3 spaces is another array that is two-dimensional. So what if we wanted a three-dimensional array, or our cube, right, where we take this into 3 dimensions? Right? So this whole thing now gets expanded 3-dimensionally. Not fantastic at this, but we'll see how this works. You kind of get the idea at this point. Right? We're moving into 3 dimensions. Okay, so we're going to stick another array inside of these boxes. I can choose whatever size I want. So let's make it a 3-dimensional array. So this is how Java would represent our cube. So I got array inside of an array inside of an array. That's a 3-dimensional array. That's the way Java represents it. And the reason this makes sense for Java is because at this point, there's no limit on what Java could do. We could easily go to another dimension. You, being stuck in your physical reality here, can only go to 3 dimensions. You only have a 3-dimensional representation of information. You can do a column, you can do a table, or you can do a cube type space. That's the only way you have, up to now, representing information. Any class that you've ever taken, you've been limited to that. 3 space would be the most complicated thing you've done. But in Java, we're not limited to that. In fact, in any programming language, we're not limited to that. We could then take this one step further. And I could say, I'm going to put in another 2-dimensional array inside of each of these. Now we have a 4-dimensional array. Now, since I can't draw any smaller, that's about as big as I can get. But theoretically, there's no limit to this. The only constructs that I would ask you to honor is that within each level of arrays, you keep all the arrays the same size. See, Java doesn't care that this is a 2-dimensional array, and this is a 2-dimensional array. This could be a 2, and this could be a 3, and this could be a 5. Java doesn't care. You might have some reason to construct something like that in the future. But for now, for purposes of keeping things simple, if you make this a 2-dimensional array, you're going to make everything a 2-dimensional array. These green arrays right here, if we make this a 3-dimensional array, every single array in each of these boxes should be a 3-dimensional array to be consistent all the way throughout. We don't want to make the last one here a 6-dimensional array. That's a stylistic approach. Java doesn't care. You can make that as many dimensions as you want. So, this gives us the ability to represent relationships of information in any dimension with many, many variables. So practically, what does that mean? Well, if we start thinking about why we need to put variables together, we can start thinking about why we would need like a 30-dimensional relationship. 2 dimensions, x and y axis, that's easy, right? Points. 3 dimensions, 3 space, x, y, z. 4 dimensions, relativity, x, y, z, t. They add in time. 5 space. Let's get silly. X, Y, Z, T, universe number. What dimension are we in? So X, Y, Z, T dimension. I know, I'm starting to make your head hurt. So you could go at as many different levels as you wanted to. Now for the practice. Shh. I would like you to create, there's 3 assignments in this. Create an array of 5 ints. Store a random number in each element and print the element to the screen. You can do that brute force. You don't need a loop. Just create an element, store 5 random numbers, use your random generator. You have to go back and look at the notes for that if you forgot. Change the program so the array had 5,000 elements. Just answer the question. How would that change your solution? Would it make it really, really tough, and why? And then part 3, write your own practice problem with arrays. You come up with your own set of arrays. If you would like to try a multidimensional array, feel free to try it, just to kind of guess how that might be arranged. It's an array of arrays. Don't do more than 2. Let's just stick with the 2-dimensional array. 2-dimensional arrays are on the AP exam. We will talk about how to actually code those in the future, but for right now, we're kind of just leaving that as something we introduced, and we're going to head down the road towards there. So work on that practice assignment, submit it here, and we'll see you next time.